Engineering is not theoretical, totally out of the question. If you tell me you are an engineer and you just know how to code certain things and then make solve some equations and whatever, no. Like the prof said this morning, you must be practical minded, nothing else. Nothing else. And my advice to you here is that after graduation, the first 5 years, if you don't make it, you run into trouble. Never, look, when I entered VRA, I was working under technicians, although I was an engineer. I didn't mind them. After a number of years, they realized that I was truly an engineer. Go down to F, make sure that you study everything that comes your way. The video games, leave them aside. My last son is also a control engineer. I fought him almost every day. Sometimes I will just sneak in to see whether he's on his video games. You can't sit here and then you are playing football with somebody in Thailand when you are an engineer. It doesn't make sense. It doesn't make sense. You are supposed to be studying, you know. And for emerging economies, engineering must now evolve faster than ever before. We must apply that knowledge that we are gathering. You know, there are people who are coming out with very simple things and then they're making good money. I'm not saying just, you start from school, then you are looking for money. It doesn't work that way. But try to be innovative. Try to think outside the box. Somebody will say, throw that box away and think. Throw it away completely. Around 1998, thereabout, when Dubai started all those constructions, at that time they said 2/3 of the world's tower cranes were all in Dubai. And indeed, anytime you went there, you see all those tower cranes there. Then I was wondering, how are they able to take this tower crane up? You know what a tower crane is? That thing that lifts, Then I said, okay, let me go to YouTube. I went to YouTube, and it's one of the simplest things that anybody can do. It's simpler than any other thing you can think of, And how did I get to know how it works? Because I wanted that knowledge. I went to YouTube. It taught me exactly how to go about it. You must work overtime the first 5 years when you leave school. Make sure that you study anything that comes your way. You look, you are watching television, CNN, and then something comes up, go, and then look at what it means. You get to some age, and there are many things you can do. When you were younger, you could be smart and do those things, but you get old, and then you can't do that. Once again, my last son came to me someday and then tried convincing me to learn coding. And he gave me some documents and everything. I started the first day. Second day, then I called him. I said, my friend, this is not for you. The ball is back in your court. Take it. It is not mine. Today's talent must be global. If you think you are just studying to be able to solve the local problems here, forget it. You must think global. You can act locally, no problem, but you must think global. Take note that whatever you are doing, you are competing with a little boy in India, very smart, who can just come out with something. You are competing with somebody in China on robotics. You are competing with somebody in Europe. You are competing, whatever. Then you go out into the international market. You should be able to compete with any other student, whether the person is from MIT, the person is from whatever. I mean, what they are teaching here, what the professors are teaching here, is as relevant as what is taught at MIT and the rest of it. It is for you to build on that and then be competitive. Think global. I mean, don't look at, we just want to solve this problem here. No. Everything should be such that if you go out, for instance, protection relays. Let me talk about protection relays. Protection relays are devices that you put in the power system such that when there is a fault on the line, it will detect, take out the power, and tell you exactly where the fault occurred so that people can go and, When we started, we had electromechanical relays when I was a young engineer. So you see the coil, you'll be using screwdriver to turn things and other things. No. Now, if you take a protection relay, it's very small, and everything is done on the computer. You have to sit down and think and program the thing properly. God being so good, we now have an aid, a savior in AI. What shall we do without AI? You can use that tool to do so many things. Really, so many things. Technology has no limit. And technology has eliminated boundaries. You are a global engineer. You are not just a Ghanaian engineer trained for Ghanaian purposes. No, that is not it. We used to think about KVIP toilets. When Professor Wright and others in KNUST did the KVIP toilet, they said, for Ghana. But that KVIP toilet is now almost everywhere. In Asia, they use it more than Ghana. Your thinking must therefore be global. I mean, you just make sure that whatever you are thinking is such that it's so competitive and then you can compete with anybody from anywhere. Your standards. There are international standards, the IECs and the whatever. Make sure that whatever you do conforms with those standards. Not that you develop your own standard here and then you mark yourself. I established GRIDCo when I was CEO of GRIDCo. Now, what is GRIDCo? The VRE pylons that you see that there's a very thin cable on top of all of them. It serves two purposes. One, for lightning protection. When lightning strikes the line, because that one is topmost, it will hit that one first, and it's connected to ground. The sheath is connected to ground so that it protects direct hit on the line. The other thing is that it carries fiber cable for communications. You know much about fiber cable. So we said, okay, why not market the fiber? Because we have them all over. So we set up GRIDCo. I turned it into a kind of a small company, got one of my engineers as a general manager. And then we used the capacity for telecommunications. We had some that we sold out as dark fiber, and some we had to light. I don't know if you know much about these things. For those who are into communications, where you have the STM32, STM64, whatever, that when you light, you're able to even give out more to people. And we're making quite good monies out of that. We had to create value. We needed to sit down and think outside that box. In fact, we threw that box away and then made sure that we came out with things that would benefit GRIDCo. So that is what global talent means. Global talent, it sees you beyond the obvious. These are obvious things, but you say, hey, what else could have been? You look at it and then you see what better thing you can come out with. I saw what some of the people use, these plastics that we have all over. You know, when you go to Kolebu, Rebecca Akufo, is it maternity ward, or whatever it is, I mean, they built something there. Now, the car park and other things, that is what they use. Somebody sat down, thought of that, and used that to make the driveway, you know. But many of us now, if we hear that, that's what they use. So this is bola rubber they've used to make a driveway for you. But it works, you know. Now let's go to the role of artificial intelligence. AI is no longer the future. It is the present. It's not like, oh, in future this will happen. I saw something on the CNN, I think 2 days ago, about some new types of computers that are coming. They call them gargantuan or whatever, so there's some funny name. And that if you're not careful, our accounts, the details on our computers, such computers can go delve deep into your computer and then get all your details. And I said, the good thing is that if they delve into mine, they only get zero money. So that's okay. They can go and do that. So in engineering, AI is already transforming power systems operations. Incredible. If you look at what is happening in the power systems now, very amazing things. You need to go to, anytime you are ready, I can arrange for a visit to the National Control Center. You go there, just go there and then have a look at the place. It looks like NASA when you enter there with the computers and sometimes when you enter, the people, when they are not even working, the moment they see you, they pretend like they are trying to move to Mars the next day, but it's a beautiful place. And that is where you can knock on and knock off any part of the country, including the academic city. So when I was coming, I intentionally told them to knock them off for a few minutes for them to see. Okay? So that is why it went off just for a brief period. Okay. So, predictive maintenance. This is AI. AI, you can have a system such that if you have your transformer, you don't go near the transformer. When time is due for certain things to be done, it will tell you straight away that, look, I've scanned through everything, and this is what you must do. When there is a problem, it's just like the diagnostic in the car. In your car, you can just go and plug in that in and it tells you everything. Same with the power systems and all those things, Then we talk about smart grids. Smart grids. When you have the convergence of so many grids, in West Africa, we have what we call the West Africa Power Pool. So as we speak, you can generate power today here and send the power to Senegal. The only break is between Benin and then Nigeria. In 2007, I led 8 engineers to Sakite in Benin to synchronize the 2 power systems. After 7 minutes, the whole West Africa power system collapsed because the Nigerian power system was not stable, but it was robust. So it swung the system, and then everything collapsed. Now, I'm told, I think about 2-3 months ago, they were able to synchronize after so many years because now we have the technology to be able to do all such things. And you will be working in such systems in future. It's not like you are working with WAP and then you are in Ghana. No. You are in Ghana and you are determining what is in Nigeria, what is in the Burkina Faso. Because when you have the synchronous system and the frequency, 50 hertz, that's what we operate. Okay, so it swings between, they have this bandwidth that you go in between. If it goes beyond some point, you can trip the whole power system. So there are people there, and AI these days can tell you all those things and readjust the system to be able to withstand whatever shocks that will be coming. There was a time that we had a major power system failure. And Accra and all those things went out. I went on radio and told them that there was a problem at Prisia, and that's what caused this whole thing. One of the journalists said, look at what the engineer is saying. The thing is at Prisia. You say it's affecting Accra. It doesn't make sense. It doesn't make sense. And these same people, you hear them talking so loud on the radio, energy this, energy that. They say this is an energy specialist. Then I look at myself, then what will I describe myself? Just misinformation. And you engineers in future, you encounter all such things, but you are going to be proper international engineers, and you are going to work to that. In my time, system monitoring relied heavily on human interpretation. You see the energy meters that you have in your houses. You wouldn't believe it. Those days, we used to use stopwatches to calibrate them. We would time them and then calibrate. But these days, you just plug something to it and it tells you whether it's working well or not. Let me tell you one basic fact. AI will not replace engineers. AI will replace engineers who do not understand AI, period. So if you want to be relevant, if you want to be relevant as an engineer, you must understand AI. At least the basics you must understand. You know, people say, oh, because of AI, we did so many. It's true. I mean, certain things will happen, you know, but that it will totally replace engineers, that may be way too far. Now, AI would give us some opportunities. And that is why I'm saying that to be relevant, you must really understand AI. At least the basics you must understand. The gaps in infrastructure that the professor was talking about. There are easier ways of doing things. And if you have the knowledge, you're able to apply it, then you get many more things coming up. In energy, transport, agric, things are getting better with AI. I am waiting for the day that we have one of those, what do you call it, the trams or whatever, those overhead trains, you know, that goes from Accra Central to Adenta, and it solves almost all the problems. Why would you want to compete with other people with your car early morning in traffic, so many hours? We need to ensure that those gaps are filled. Now, you come in here, you are a mechanical engineer. Yes, study your mechanical engineering very well, but try to understand the other engineering subjects. Some civil engineering, some biomedical engineering, because biomedical engineering and even mechanical engineering, they have some links somewhere. Biomedical engineering is linked to virtually everything, electrical engineering, all those things. Try to understand, because it is very possible that you could occupy a position like a Director of Technical Services in VRA. That one you must understand every bit of the fields. It's important. So much as you have settled on a particular course, also look at understanding the other courses as well. That's good. I know of this guy who was in my hall, Queen's Hall in KNUST. He studied architecture. Now he's a complete electrical engineer, although he hasn't got a degree. You know, he's been able to study that. You know, so yes, make sure that you master wherever you are, but understand the other bits. So let me take myself as an example. I'm an electrical engineer, but I understand finance because I have an MBA in finance. I have an MPA in public policy from the Harvard Kennedy School. So when it comes to policy, I understand. So if I become the president of Academic City, please, I'm not taking your position. Just relax. Mr. President, relax. With all those engineering things, other things, all the financial things happening within the university, I must know and I must understand. You take a financial statement, you must understand everything. You know, quiz mistress, she will ask a question. Sometimes a totally different subject. And then, not that she just has the answer to say yes or no. No, she will explain to you why you are getting it wrong. It means you understand the subject. You get me? So don't be that narrow-minded. You want to just occupy, you want to protect your space and stay there, comfortable zone as they normally call it. Understand other people's fields. They say if you speak a particular language and you hear some other people speaking a language, so they say, oh, that's their language, I don't even know where it's from. I'll not listen to them. When you insult them, they understand your language. They'll know. But when they want to insult you, they will take you to the cleaners and you'll never know. So try to understand all certain. Don't let the other engineering fields bully you. Make sure that at least you get a little bit of whatever they have. Now, to develop the power system, there are so many aspects of it. And it includes tariff setting. Tariff setting, normally the economists are the best, I tell you. They really understand how to go about it. But there are engineers who are equally good at tariff setting, just because they went that way to study that subject. One important thing that I would want to tell everybody here is about discipline. You must be disciplined. You know, we have GMT. What is GMT? GMT is what? Is it Greenwich Mean Time? No, that's Ghana Man time. Okay? They tell you that the thing is at 10 o'clock. Then you come at 11 o'clock. It does it. I was telling Tanko, my house is near, but because I know there's traffic here, this afternoon session, I came and I parked and I was just listening to the radio in my car. Look, if you're an engineer and you're always late, then there's something wrong with you. You must be punctual. Yeah. So, okay, yeah. So, let me urge you to do the following. 1, continuous learning. Read beyond your coursework. Learn new tools and technologies. Stay updated with global trends. There is this program on BBC on technology. I can't remember the. I think it's normally on Sundays or something. But they come out with the new trends in the, Now, it's interesting. The presenter used to be the cameraman for the show. There was a day they went, and the man himself was not there. So the presenter took over. He did very well, and now he is the presenter of that program. He just studied all those subjects, and I can't remember his name. Your work ethics. Very important. Don't cut corners. In engineering, assuming you have a blown fuse, 5 amps, you are lazy enough that you can't go and then get a replacement. Then you take that wire, you bridge it. The next time around, you will run into trouble. That whole machine could burn. That whole machine could burn. And you would imagine that you are working on a generator in Akosovo, 165 megawatt, each of the generators. And you do that. To even bring the burnt generator out for repairs, that is another 1 year. And you know what that will be costing the country. No shortcuts at all in engineering. Make sure that you do the right thing. If you don't do that, it will result in losses economically, and in fact, sometimes you can cause the loss of lives. Integrity. Don't cut corners. Number 1, safety. When you are working, number 1 is what? Safety. Number 2 is what? Safety. And number 3 is safety. it's important. You need to get into an area where there's confusion in terms of engineering, something collapses, other things, and you know that, look, maybe somebody somewhere omitted just a single thing, and that was the cause. Your engineers, you must make sure that whatever you are doing, you pay attention to safety. In VRA, the slogan is this: no emergency is so serious that you cannot take your time to do it safely. That is it. No matter the emergency, make sure that the safety aspect, you respect that, and then go by that. Otherwise, you run into problems. Now, as part of what I'm supposed to be talking about, we were talking about sustainability. Whatever you do, in order to sustain it, you just have to update yourselves. There is this teacher lesson, whatever they call it, where the teachers will have to go, And I think in the US, the medical doctors, some of them, they normally have to go back and write exams again to be able to, But you will not do that. Just make sure that you test yourself and then you answer your questions. The only way you do that is to continuously update yourself. Then now is the subject of the various COPs. You know what COP is? COP. It's a COP 27, COP what, or whatever. COP means Conference of Parties. Okay? And they don't play with the environment at all. And various countries are also trying to meet their standards. Okay? So you are going to be working with renewable energy integration. You will be doing energy efficiency jobs, maybe climate resilience, and then whatever you do, think of the environment. I remember some Japanese group was doing some telecom work around Akosombo, and a Ghanaian driver was driving the Japanese technician. Now, when they were going, he saw a rat or something running across the road, so he wanted to kill the rat, went off. The Japanese man unfortunately died because he wanted to kill one rat. Why do you kill the rat when it's in its environment? That is whatever. Let's respect the environment. The engineering work that you do, you must respect the environment. ECG wanted to pass through the Achimota forest some time ago, and then the Forestry Commission said, no way, you can't pass there. And you must respect that. You must respect that. It may result in extra costs in diverting the line and other things. But let's think about that. It is real. Climate change is real. I know some president who doesn't believe in it. I've not mentioned anybody's name anyway. But for me, I believe in it. And I think that, when we were kids, the rain party in Accra and what is happening now, totally different. Totally different. And those are all indications. So sustainability is not an add-on. It is a standard. Just make sure that what we are doing, whether in your profession, whether the environment and everything, we think of that. Now, the universities, I'm just concluding, must integrate AI and digital skills in whatever you are doing in your teachings. You must encourage interdisciplinary learning. Industrial links, you must strengthen them. But I know the challenges you go through with the industries. They don't want to spend the money. But you'll still try to see how you can get that. Industry must invest in training. Every year, at least, part of their expenditure should be training of students, buying equipment for the universities, and that will make the country a better place. For instance, the plastic companies can come to Academic City, say, we are sponsoring 5 students, your project work, you should study, you should do a research on this and that and that and that. It's not expensive, but they wouldn't like to do that, So let me now get to my good friends, the students. Take ownership of your development. It's yours. Own it and make sure that you come out, as they normally say, what? In golden colors. You must pursue excellence beyond the classroom. Not just what you've come to learn that you can prove to somebody that this equation doesn't work, this, no, whatever. No. You must think locally. If you want to act, globally, but if you want to act locally, that's your own business, but think globally. So, let me conclude by a personal reflection. I started my career, like I said, in 1985. Ghana's power system was not developed. Over the years, I've had the privilege to help extend electricity to northern Ghana. I was a commissioning engineer. Restore systems during crisis. Lead GRIDCo to become one of the best, actually GRIDCo won the best utility in West Africa on 2 occasions when I was CEO. I've trained and mentored engineers. Many of the past engineers, the last 5 to 8 years, CEOs all went through me, and I'm proud of that. But the truth is, the work I have started, the work Prof has started, yes, it's ongoing, but it's not finished. If work could be finished, we would have all packed and then gone home to our villages. I know his village, he doesn't know my village. We'll just go. But there are other people left behind. Who are they? You, the fellows here. So what are we going to do? We are handing it over to you. Can you make Ghana a better place for us? I need your answer. Can you make Ghana a better place for us? So say, yes, we can. Yes, we can. So you are all in this room. We are all witnesses. We've heard what you've said. And what we'll do is I will ask for God's blessings for all that you'll be doing in future. God bless you in all your endeavors. You will become great engineers. And someday, when we visit you, then we shall be proud that we trained you here in Academic City. Maybe now you are earning far more than we earn, but we don't mind. You keep your money, but we are happy that you are doing well. So God bless you all. Thank you very much.